Hello, I'm going to shoot a quick video for those of you that are having some trouble still trying to figure out how to do regression. This will be for Module 3, so that will be exponential regression. I'm going to look at specifically number 7 in the 5.4 homework that deals with some data they want an exponential model for, and it's also an application so we can answer a few questions. So let me show you the problem that I've got in my set. These are the numbers that was generated. So what this data is showing us, we've got the year as our input values, and then the function values, the output values are supposed to be total personal income of a country measured in billions of dollars. That's important, the unit is, because we have a question down here that's referring to the outputs in trillions. That's not the unit that is shown. So remember, a trillion is once you get to 1,000 billion. So keep that in mind for later. All right, so let's put our data into Desmos. Hopefully you've been doing this a little bit with linear and quadratic already, so you have some familiarity with Desmos. But what we can do here is just, you can go and click on this to copy the table, and it will show you some data that you can then highlight and put on your clipboard. And then when you go to Desmos, which I'm going to do right here, you can just click on the first line and do, now the paste, you'll have to use probably the clipboard, the keyboard functions, Control V, but this is what it looks like when you drop the data in there. Notice we have the whole entire year, we have the outputs, this is in billions, and it goes ahead and adjusts the window for us so we can kind of see the shape of the scatter plot. Do you see why they're asking for exponential regression? It does have a flat kind of a start and then it pulls on up. The difference though between what I have here and what the problem asked for is it said it wanted the X values to represent the years after that start year, 1959. So we don't want to have to look at these points and look under them and read off 1,959 or 69. We would like that first point to have an X value of 0. So we do need to go back and readjust our X values if we've done the copy and paste version. You can also just type them in by hand, but this will be year 0, 1959. Basically, you just subtract 1959 from each year, and it goes up by tens. So 1959 will be X equals 0. The next one is 10, 20, 30, 40, and then there's only a 5-year gap down here, so it'll be jump from 40 to 45. So I'm going to go ahead and readjust those. So that would be 0, 10, 20, 30, 40, and 45. Okay, now we can't see the scatter plot anymore, so I'm going to go down here and do the zoom fit to readjust the window so I can see the scatter plot. I mean, I know they probably didn't ask for a scatter plot, but if they did, let me see, maybe I have to match it to a picture. Do they ask us to match it to anything? A, B, no. Okay, so the picture over here is just for fun, but what we need is the exponential regression. So once we have the data in there with our X values correctly realigned to the start year, now we're going to go get our regression. This one is a little bit tricky. When you go to do the regression, command up there, these are all the different drop-down menu choices. The default is linear. We want to go all the way down to exponential regression. And there are different ways that it does the calculation, but the one that's going to account for the closest fit would be if it is in the log mode. So we do have to switch the log mode on like that. So you select exponential regression, click on the log mode, and then these will be the values that you can round to whatever it's asking for. Just to see now the first point was year 1959, but that's an X value of 0, and it just goes up 10, 20, 30, 40, 45. Okay, so these are the values that I'm going to type into my math lab in terms of the accurate to 3 decimal places kind of a thing. So that will be 445.88. Now that third one, 5, is followed by a 1, so I will keep the 5 there. And then times, now my base number, this basically tells us by what percentage it's increasing. So 1.076 means it's increasing by about 7.6%. So 07, that 6 will stay because it's followed by a 3. All right, so give me a chance to go put that into my first one so we can get to the next value. So the first value is 445.885. 445.885 times. and the base is 1.076, 1.076. We're going to raise that to the power of, and that's where our x goes because we're in our exponential, what am I doing here? In our exponential regression function. Okay, so when you have an exponential function, your variable is in the exponent. So that's what it is. Let's see if I rounded correctly. Okay, so now the next part is it asks us just to use this function, not the overall one, but this function to answer the next question. So the overall personal income in 2009. Well, we don't have 2009 in our data set anyway, but even if we did, it's asking us to use this model. So we have to figure out, all right, let me turn off my phone. We have to figure out what X value is represented by the year 2009. Well, if you take 2009, subtract 1959, that's 50 years. Or you could also look and notice that it's only 5 years after the last one in our data set. Remember, our last X value is 45, so we add 5 to that, so it's 50. So I need to evaluate this when X is 50. Now I notice it doesn't say whether to use the rounded or the unrounded values. So let me go back to this. If you do this where you copy the equation, we've done this earlier, if you will just click on that, it will enter it into the next line as its own separate equation. So then we can type in inputs and outputs. So if I want to do where X is 50, I can either do it visually, where I can just type in on the next line here, X equals 50, and then see where it intersects this curve. I may have to zoom out just a little bit. But if I type X equals 50, it'll intersect it right up in here somewhere, and I can get it that way. Or I can also just use this. I guess I can call it a function, or I can add a table to it. I'm just going to replace it with the function notation. Oops. Maybe I can get my typos there. And then I can just type f of 50. And it's telling me 17,623.48. So that's actually using the model here. It's unrounded, so hopefully that will be what my math hub wants. Or notice this is another way you can do it. You can do it visually and just do X equals 50, and that should draw a vertical line right here at 50, and where it crosses the line. So look what that Y value is, 17,623.4822. It's the same as this number here. This one's got a few more decimal places shown. All right, so let me write that down so I can see what they want us to round it to, 17,623. So let's go back to that. Round to 3 decimal places as needed. So the decimal places were 0.4822. So that rounds to 482. So 17,623.482. And let's hope that they also used the unrounded values when they checked on that. All right, so let's go back and round it. We can put, well, let's see, 4822. Let's go look at this again. So 482. All right, let's see if we do the rounded version. Sorry, let me just see if they wanted us to literally use the rounded version. So 8851 would just be 885, and 07631 would just be 076. Now let's see if that changes it. What we did was actually more accurate. Yeah, it does change the output a little bit. So they're using the rounded values that they asked us to type in. So let me type this in instead, 17,371.464. All right, so sometimes they'll take both the rounded and unrounded values. This one seems to not want that. They want us to put exactly the same numbers that we typed in part A. So 17,371.464. Okay, how about that? So it didn't say, but it wanted us to use the rounded values rather than the more accurate unrounded values that you can just copy automatically. So we use this, plug that in for 50. Because if we go back to the graph again, if we wanted to verify that graphically, let's try our X equals 50. And that place where it crosses has been adjusted also. So, well, No, it doesn't. It looks to me like it's using the unrounded thing in the graph. So just never mind. Let's just go ahead and move on to the next one. So let's use the actual function, plug the number in. And then the last question is a little bit tricky. It says the total personal income will reach 21 trillion in the year, blah, blah, blah. So notice that these outputs are in the 10,000, 17,000. So 21,000 would be the 21 trillion. So instead of saying, so this is 17,374 billion, we could also call this 17 trillion, 371 billion. So we want 21 trillion. We want to find out when the output is 21,000. All right, so again, let's see here. Easiest thing on this one be to just type in y equals 21,000. See where that intersects. Okay, so look at that x value, 52.589. Okay, so when it says during what year, that means we have finished the 52nd year and we are partway into the 53rd year. Okay, so it says round up to the nearest year. Okay, so remember 2009 was 50, so we need to round that 52 point whatever up to 53. So that'll be 3 years after this, so that'd be 2012. Okay. All right. All right, so if the difficulty is just getting these numbers right, remember that you're going to put the data in, adjust your x values, ask for an exponential regression, and then be sure to check that log mode on. Make sure that that is switched on, and that will give you the correct values here that you round to 3 decimal places. The next question is going to ask you to use that rounded values function to make an estimate for another year. So you take that year minus your start year, and that's the x value you plug in right there, and that will get you your estimate for that output. And then the third question is giving you an output, 21 trillion or whatever your problem is. Remember to convert the trillions to thousand billions. So 21 trillion is really 21,000 of these units, billions. So you can just, that one you can solve graphically. You can just type in y equals 21,000 and take a look at where it crosses that function, read off the x value, round it up to the next whole year, add that to 1959 or whatever your start year is. That's how you use these models to answer basic input and output questions. The input, I went ahead and just plugged a number in for x and worked it out. The output, I just used a quicker method where I just cut a horizontal line through the graph of the function where it says y equals the y value we're interested in, and then read off the x value. Okay, so I hope that helps. I will get this uploaded so that I can get that out to you.